Now we're going to move into one of the most important applications of inverse functions, derivatives of inverse trigonometric functions. Let's start with this example. We want to find the derivative of g of x equals sine inverse of x, and we want to use the inverse function theorem. The inverse function theorem says g prime of x equals 1 over f prime of g of x. We have g of x equals sine inverse of x. We need to find f prime. And in order to find f prime, we need to have f of x. So the relationship between f and g in the inverse function theorem is that they are inverses of each other. So we let f of x be the inverse of g of x. So since g of x is sine inverse of x, so the inverse of sine inverse is sine. So my f of x equals sine of x. Now I need to find f prime. F of x equals sine of x. F prime of x equals cosine of x. Now I need f prime of g of x. So I'm substituting g of x into this function. F prime of x equals cosine of x. F prime of g of x equals cosine of g of x. And g of x equals sine inverse of x. So I replace g of x with sine inverse of x. Now I need to simplify this. To simplify cosine of sine inverse of x, I'll let sine inverse of x be alpha. So I have cosine of alpha. And I need to find cosine of alpha. Now, alpha equals sine inverse of x. That means x equals sine of alpha. Sine of alpha equals x, and x is the same thing as x over 1. Now, let's put this in a right triangle. Let's call this angle alpha. Does it have to be this angle? No, it could also be this angle. So this is alpha. This side is the opposite side of alpha. This side is the adjacent side of alpha. And this is the hypotenuse. Sine of alpha equals opposite over hypotenuse. Sine of alpha equals opposite over hypotenuse. So my opposite is x and my hypotenuse is 1. And this alpha is the same as this alpha. So to find cosine of alpha, I need adjacent over hypotenuse. To find this side, I use the Pythagorean theorem. A squared plus b squared equals c squared. So to find this, I'll take square root of c squared minus a squared. So for cosine of alpha, I'll take square root of 1 minus x squared divided by 1, which is square root of 1 minus x squared. So I have f prime of g of x equals square root of 1 minus x squared. Now I plug that into this formula. And this is the derivative of sine inverse of x. Now, instead of doing this full process every time, we summarize the results in a table. The derivative of sine inverse of x is 1 over the square root of 1 minus x squared. The derivative of cosine inverse of x is negative 1 over square root of 1 minus x squared. The derivative of tangent inverse of x is 1 over 1 plus x squared. The derivative of cotangent inverse of x is negative 1 over 1 plus x squared. The derivative of secant inverse x is 1 over absolute value of x times square root of x squared minus 1. And the derivative of cosecant inverse x is negative 1 over absolute value of x times square root of x squared minus 1. So the key idea is all of these formulas come from the inverse function theorem, and we use triangles to help simplify expressions. Once you understand where they come from, they're much easier to remember.